Okay, today we're going to go over the law of sines, law of cosines, and also a little bit on right angle trig, all of which will be on your quiz that will be held the beginning of next week. So looking at this, we have this little outline which has you think through which of the different laws that you're going to use to figure out what you have to figure out about a given triangle. So start over here. You always want to start with a sketch so you see what they're doing. So if they don't provide one for you, you should do one for yourself. If you're looking for area for any triangle, you now have this new rule. So make sure you know how to use that. If your triangle is a right triangle, then you can just use SOHCAHTOA for everything in terms of finding missing sides or missing angles. And in fact, for the area, if you want to, for a right angle, you can just use 1/2 base times height, and you can get the area that way. That only works for a right triangle. 1/2 AB sine C works for any kind of triangle. Okay? So let's say it's not a right triangle. Let's say it's some other kind of triangle, and you can't assume that there's any right angles. So if you're given side angle angle or angle side angle, you're going to use law of sines. And here is the law of sines. Remember, you can use that to get a side or an angle. Okay, if you're given side angle, okay, if you're given one angle, you may have the ambiguous case. So you have to figure out if you have 0 triangles, 1 triangle, or 2 possible solutions. And that's all law of sines. If you're given instead side angle side or side side, you're going to use the law of cosines. And you're going to use that either to get a missing side, which is this formula, or a missing angle, which is this formula. So we're going to give you the formulas. It's up to you to understand when to use it and to use it correctly. So inputting it into your calculator correctly is going to be extremely important. So I highly recommend you stick with one calculator and you know how to use it well. Okay, let's go on to our problems. So here are some pretty easy ones. It's all calculator input. So it says solve for angle theta, round your answer to 1 decimal spot. So what you're basically going to do for all of these, so for 1 through 6, you're going to use inverse trig. So I'm going to say you're going to use inverse trig. Remember your mode. The mode is degrees for this entire thing. Everything's going to be degrees. And I want this particular problem solved to 1 decimal spot. So what you're going to put in your calculator, I'm only going to do this probably once, sine of -1 of 0.5534. And you should get 33.6 degrees. If you put the inverse cosine in, you should be getting 56.4 degrees. Inverse tan, 29.0 degrees. This is rounding to the nearest tenth. Inverse cosine again, 24.1 degrees. Inverse sine, 65.9 degrees. And inverse of tan, 42.4 degrees. Now, I can't say this enough. If you are simply copying down this answer while listening to music, you are being very, very foolish. You should be making sure that you are comfortable putting this in your calculator and getting these answers. And if you're not doing that, you have to figure out what's wrong and why are you not doing that. Okay? All right, what 2 angles? So this is going to be a little different. The first angle is going to be in quadrant 1, and the second one's in quadrant 2. If you're going to deal with sine of beta is 0.8192, what you would do is you would say sine to the -1 of 0.8192. That's going to give you an angle in quadrant 1 that's going to be 55 degrees. In quadrant 2, sine is also positive. Therefore, the angle in quadrant 2 that has the exact same sine value is going to be the complement to 55 degrees. And you get that by saying 180 minus 55, and that should get you 125 degrees, and that's a quadrant 2 angle. Okay, for cosine and tan, what's going to happen for both of these? In quadrant 1, okay, so this is quadrant 1, everything's positive. Sine is positive, cosine's positive, tan is positive. In quadrant 2, sine is still positive, but cosine is negative, and tan is also negative. So how do I get the matching angles then? Well, if you're given a cosine angle and the negative value, what you should say is your theta in quadrant 1. So quadrant 1, you get that by saying cosine -1 of 0.669. And you should be getting 48 degrees. This negative value will occur in the second quadrant for the supplementary angle. So 180 minus 48 gives you a supplementary angle of 132 degrees, and that is your second angle. So this is the quadrant 2 angle, this is the quadrant 1. Quadrant 1, quadrant 2. Do the same thing for tan. Your quadrant 1 angle you get by saying tan to the -1 of 0.7535, that's inverse tan, and you should get an angle of 36.0 degrees. Okay, the quadrant 2 angle you get by saying 180 minus 37.0 degrees, and that's going to be 143 degrees. Okay, so that's my second angle. So I've got this one in quadrant 1 and 143 in quadrant 2. Okay, so it says solve the following right triangles. And they're right triangles, so that means that you're going to be using SOHCAHTOA. Okay, I have no angles for the first triangle, so I can get the missing side. I can use Pythagorean theorem, which tells me that c squared equals a squared plus b squared. So c squared equals the a side is the 12 squared, the b side is the 5 squared. So therefore c is going to be the square root of this, and I get c to be exactly 13. Okay, this is a Pythagorean triple. So it's exactly 13. So now let's get our two angles. I need angle A and angle B. So I said the sine of angle A is 12 over 13. And when I did inverse trig, I got A is 67.4 degrees. I then said 90 minus 67.4 degrees, and I got 22.6 degrees because I know those two acute angles, angle A and angle B, they're the acute angles, are going to be complementary, which means they sum to 90. Okay, done. So I got those two angles for you. Okay, next one, same idea, only this time I have one angle, and they told me it was a right triangle, so therefore I'm allowed to put my little right angle here. A little better. So hold on. Okay, here's one line, and then here's the box, and that's good. Okay, so angle Q right here is going to be 90 minus 36, which is 54 degrees. Okay, so now I need this little r, and I need this little p. So to get the little r, I'm going to say the tan of 36 equals r over 11. This is a one-step problem. Do your cross multiplication, and you should be getting r equals 8. And it was 8.0 because it said round to one decimal point. Okay, the next one I did, cosine of 36. That's going to be 11 over p. And my p ends up being 13.6 after doing cross products. Notice I don't have degree symbols on them because they are not degrees. They are your side lengths. Okay, so next one, another right angle trig problem. So you're going to draw your triangle. It's a right triangle. Draw the triangle first. and then we'll fill things in. A tower in Montreal, Canada is 227 meters high. Okay, that means that this is the tower, and that height is 227, and it is in meters. Okay, a stake is located 90 meters from the base of the tower. Okay, right here is where the stake has been placed. It is 90 meters from the base of the tower, and a wire runs from the stake to the top of the tower. That means that this is the wire. Find the observer's angle of elevation to the tower's top. That's this angle right here. Theta is the angle of elevation. Make a sketch and show your work. Okay, all you have to do is find the angle. So to find that angle, that's a tan problem. The tan of theta equals opposite over adjacent. And when I do my inverse trig and put this in my calculator, I get that theta equals 68.4, and it's in degrees. Okay, done. Okay, we've got two more right angle trig problems. These are all from 5.4, which is on your quiz. So again, get yourself a right triangle. Okay, here's my little right angle here. Okay, a 500-foot wire runs from a stake in the ground to the top of the observation tower. So that means right here and right here is our tower. Here is your stake in the ground. If the stake is 200 feet away from the base of the tower, that means right here is 200 feet. What is the wire's angle of elevation? This is where the angle of elevation is. They also told me that the wire, which is right here, is 500 feet. So those are the values I have. So they want to find the angle of elevation. So what am I going to do? I'm looking at that and I'm saying, I'm looking at that angle. I have the adjacent and I have the hypotenuse. So I can say the cosine of the angle is adjacent over hypotenuse. And once you do your inverse trig, you're going to get the angle of 66.4 degrees. Done. Okay, one more right angle trig problem. Get your right triangle. An 800-foot wire, an 850-foot wire. Okay, so here's your wire once more, and this time it's 850 feet, runs from a stake in the ground, here's where the stake is, to the top of a 670-foot tall building. So that means your building is here. So this is the building. And it is 670 feet from here to here. What is the wire's angle of elevation? Again, angle of elevation goes there. So from that angle's perspective, I have the opposite and I have the adjacent. So this is a sine problem. After I do my inverse trig, I should get my angle is 52.0 degrees. Okay, moving away from right angle trig. I now have a triangle that's not a right triangle. And when I read this, I see that I have points A and B are located along a stone wall and separated by 80 feet. Okay, so here's my 80 feet. This is my stone wall. Here's the 80 feet, and that's points A and B. Okay, you plan to create a triangular fence. Let point C serve as the third point of the triangle. So I put that here. So now I'm going to make my triangle. Okay, the angle made by the stone wall and the line that runs from point A to point C measures 41 inches. So right in here, that is 41 inches, 41 degrees, excuse me. The angle made by the stone wall and the line that runs from point B to point C measures 52 degrees. So right here, that is 52 degrees. What is the area of the triangular fence? Well, that's an interesting question. So I have some things to think about. I know, for one, that I can get angle C, which is up here, by just doing subtraction. So say 180 minus 41 minus 52, and that's going to get you an angle right here of 87 degrees. And I also know that I need to have an angle that's included between two sides in order to get my area formula filled in. So what I'm going to go for is I'm going to go for a little a. Because if I have these three pieces, I can then get the area of this triangle. So because I have a pairing, I can use law of sines to get the missing side A. So the magic pairing I have is this. I know that sine of 87 over 80 will equal sine of 41 over A. Do your cross products and isolate your A, and you should be getting little a equals 52.6. So just to show you how to do that, you would say A times the sine of 87 equals 80 times the sine of 41. You would then divide both sides by sine of 86. That cancels. This is what goes in your calculator. That's how I got A is 52.6. Okay, next thing. Now that I know A is 52.6, and I know area equals, well, the formula is 1/2 AB sine C. You're not going to match up those angles exactly. What that means is you have 1/2 times a sandwich. And the sandwich is side, the next side, and the sine of the angle in between them. That's what goes in your calculator. Okay, 1/2 80 times 52.6 times sine of 52, and you should get an area of 1658.0. They gave it to me in feet. Area is feet squared. I would expect that you're going to give me the units back if I give you units. So just to recap, you had to figure out how you're going to handle area when you don't have enough information about the triangle. So what I did was I got the missing angle. That was angle 87. I used law of sines because I had a pairing. Remember, as long as you have a pair, you can use the law of sines. I got the missing side A. That gave me this little trio, which is the side, and the included angle, and I was able to then use the formula for area and get the area that was required. So that was it for 15. Okay, for these, they want us to solve the following triangles. So we're going to be using law of cosines to solve these. So there's a lot of work for these. I'm going to show a lot of it, but probably not all of it. So you're going to have to work some of these out yourself. Okay, number one thing you're going to do is you're going to draw a triangle. So my triangles, show what they're looking like. I did ABC. And so little side A is 25. Little side B is 24. Little side C is unknown, but angle C is 74 degrees. This is a situation where I have side angle side, and that is law of cosines because I cannot get a pairing to be able to do law of sines. So the first thing I did was I said, okay, to get missing side C, law of cosines tells me C squared equals, and these letters do match up because I'm going to make them match up, a squared plus b squared minus 2ab cosine c. Okay, so what I'm going to do is I'm going to say, well, I don't want c squared. I want c. So I'm going to start plugging in these numbers, but look what I just did. I'm taking the square root of the whole right-hand side. My a squared is 25 squared. My b squared is 24 squared minus 2 times 25 times 24, and then times the cosine of angle C, which is 74 degrees. That goes in my calculator all at once. I can't stress that enough. That will get you a value of 29.5. So you have an angle, you have a value of 29.5, and now you need to get one more angle, and then once you have that angle, you're going to be able to use subtraction to get the third angle. Okay, so this is the first time I use the law of cosines. Now I'm going to try to find angle B, and to find angle B, I'm going to take my formula and I'm going to change it to this. The cosine of B equals a squared plus c squared minus b squared over 2ac. So things to note, this b squared is as far away from this b as possible, and it only appears one time. So in terms of understanding how to work through this equation so that you can use it no matter what your letters are, that's the big key. Okay? Same thing with the side formula. Notice that this C and this C are very far apart, and the C only appears once on the right-hand side. Okay, so I'm going to have to use inverse trig of that whole fraction, that whole quotient. And when I do, I get angle B is going to be 51.4 degrees. Okay, so that's another value that I needed. So this is one of the ones I just got was 29.5. Now, this is angle B is 51.4, and I needed that as well, and I solved for that. To get angle A, just do subtraction. So to get A, you're going to say 180 minus 74 degrees minus 51.4 degrees, and you should get angle A to be 54.6. Okay, so that's how you do it. When I start using law of cosines, I keep using it. I don't switch over. Okay, so that brings us to 17. Let me just box off 16 in red. So this was all 16 right here. Okay, so changing colors. I'm going to draw my triangle. Oh, and I had to say one thing. They also told us to compute the area of the triangle. So what I did was I used this. I'm going to do this in maybe green. I used these values right here. This is my little trio. So to get my area, and I'm going to change that to maybe blue. So area is 1/2 AB sine C. So it was 1/2 24 times 25 times the cosine of 74. And I got my area to be 288.4. I don't have any units, so I'm just going to leave it at that. But they did ask you to solve for area as well for every one of these problems. Okay, that brings us now to our next problem. So for number 17, draw your triangle. Remember, draw it not as a right triangle because you don't want to assume it's a right triangle. It is not. So this is X, Y, and Z. So Z, oh, sorry. What did I just do? Let me do that again. So this is Z. Okay, so Z is 36 degrees. Z is 36 degrees. And x, which is across from big X, is 11, and y is 18. Okay, so right away I could do area because I have all the right things, right? So why not do my area? So the area is going to be 1/2 11 times 18 times the cosine of 30, the sine of 36. Okay, times the sine of 36. So area ends up being, let's put that in my calculator, 11 times 18 times the sine of 36, and I get 116.4. Okay, 116.4. Okay, let me just take that under advisement for a second. Did I put that in correctly? Oh, no, I'm so sorry. Let me do it again. I neglected the 1/2. Okay, so 58.2 is what it is. Okay, area is 58.2. Done. Okay, now let's get the other pieces. So I don't have a pairing, so I have to use law of cosines. First thing I'm going to do is find z. So to find z, I'm going to say that z squared equals x squared plus y squared minus 2xy cosine of 36 degrees. Okay, you've got to be able to switch these formulas around. So z equals the square root. So x squared is 11 squared. Y squared is 18 squared minus 2 times 11 times 18 times the cosine of 36. So when I solve for z, I get 11.2. Done. Okay, now get one angle. I'm going to do the cosine of y, and I'm going to say that that's going to equal x squared plus z squared minus y squared over 2xz. Okay, when I plug in my numbers, they are going to be, well, I'm going to do this. By the way, also, I'm going to say y equals cosine -1 of x squared is 11 squared plus y squared is, what did I just do? Hold on one second. Plus z squared. Oh, I see what I'm doing. Okay, hold on. Let me just regroup for 1 second because I changed what I was doing. Okay, that's good. So z squared. Okay, so I'm trying. Oh, I'm so sorry. I got z. Z is 11.2. I didn't put it on. Okay, so 11 squared plus 11.2 squared, right? Go 1.2, and let me erase this. And that's 11.2 squared minus y squared, which is 18 squared. All of that is over 2 times 11 times 11.2. And I end up getting my angle y is 108.3. And doing subtraction from 180, I get my angle x is 35.7. Okay, you're going to continue doing these the same way. Let me just sketch these out for you. If I have something like this one, notice I have no angles whatsoever. I am definitely using law of cosines. This is ABC, then this is 13, this is 24, this is 15. Okay, cosine of angle B is going to be a squared plus c squared minus b squared over 2ac. Angle B ends up being 117.8. I do it again. Cosine of angle A is going to be b squared plus c squared minus a squared over 2bc. And I end up getting angle A equals 28.6. By subtraction, angle C will be 33.6. Okay, so I gave you my setup. Now you're going to have to think through it and make sure that you can get that setup, because it may not come naturally for you to be able to switch these equations around. So you have to spend time getting that. Okay, we still need our area over here. So what I said was this is 33.6, and I used this little trio right here. So area equals 1/2 13 times 24 times the cosine of 33.6. And I got an area equal to 86.3. Did I do this other area for you? Yes, I did. So let's go on to 19. 19, draw your picture. When I draw it, I had this be D, E, and F. And again, I have no angles. I'm definitely using law of cosines. I'm going to use it twice. This is E, that's D, across from capital E is little e, across from capital F is little f. So I tried to solve for cosine of D, which is going to be E squared plus F squared minus D squared over 2EF. Make sure you can resolve that for yourself. And when I did that, I got angle D to be equal to 76.5 degrees. Then I went through cosine of angle E, and I said that's going to be F squared plus D squared minus E squared over 2FD. And I got angle E to equal 43.9. By subtraction from 180, I got angle F to be 59.6. Okay, those are all degrees. So then I put angle F in as 59.6. I used that trio, and I got my area using that trio to be 19.7. Okay, done. So you may have to go back and spend more time. That's what my expectation is for you. If you think that you can just go through this once and have studied for the quiz, you are incorrect. Have it. Okay, let's do 20. So doing 20, let me just make sure I have this correct. Yep, I'm good. Okay, so doing 20, I look at that and I see I have 2 angles and a missing side. So let's look at this and see what we have. So here, I'm going to draw this triangle. This is A, B, and C. So look at A, B, and C. B is 39, C is 111, and little b is 89. Well, let's look at this. I was given 2 angles. Can't I get the third angle by just subtracting from 180? And the answer is yes, I can. That opens the door for law of sines. And it's not the ambiguous case because they gave me 2 angles. So let's use law of sines. So I can say, I have my pairing, the sine of 39 over 89 equals the sine of 111 over side C. Doing your cross products and isolating, I got side C to be 132.0. Okay, so that was 132.0. And then once I have that, what do I know now? I can go ahead and use that same pairing, sine 39 over 89 equals sine of 30 over little, this should be little c. So this should have been little, let me just see 1 second. So I may have changed my lettering, so give me 1 second. So that should have been 132. Yeah, so I'm okay. So then I want to have, oh, I know what. I'm just going to rearrange my letters here so that I match my work on my other sheets. Let me just do that quickly. So make this, so let me rearrange these letters so that it matches what I have on my worksheet. So this was B, this was A, no, this was C, sorry, this was C, and this is A. Okay, so now it matches what my work is, so that's good. So little side C, 89's over here, across from the 111, across from the 39, 89, across from the 39, Okay, let me just do this one over. I apologize. So let me do this correctly so that we have no confusion. Because this is our first law of sine, so I want to make sure I have this set up all correct. Okay, I've got to use what they gave me, which is this. So here is my B, which was 39, and across from the 39 is indeed the 89. Then I said, let's make this C, that's 111, and then I have, this is remaining, has to be A. I do my subtraction, I get the missing angle of 30, and that's all they gave me. So I need everything else. So I'm going to need this side and this side now. I got this side by doing mere subtraction. Okay, so my pairing was sine of 39 over 89, and that equaled sine of 111 over little c. Little c ended up being 132.0. Done. So that was one that was missing. This is 132.0. It makes sense it's big. It's across from the biggest angle. Go back to your pairing, and you're going to say, okay, I still need across from angle A. So this is going to be little a. And when I do my cross products and I isolate, I get 70.7. And that's little a. And that's 70.7. Okay, they want me to do area as well. So what I did was 132. I did this little pairing here. I tend to use the right corner for some reason. So I said my area equals 1/2 132 times the 89 times the sine of 30, and I got an area of 2937. Okay, so done. So that's done, and now let's go to the next one. Okay, so look at what they have for this. I have this triangle, and I drew it as JKL, and I said that angle J is 39, angle K is 34, little l is 19. Okay, now I can get angle L by doing subtraction. When I subtract from 180, I get angle L to be 107 degrees. I see that this is a law of sines because law of sines tells me I need a pairing, and I have that pairing. So now set up your magic pair, which is sine of 107 over 19 equals sine of 39 over little j. And j ends up being 12.5. Okay, so then I'm going to do the same magic pairing. And it's going to be the sine now this time of 34 over k. And psi k ends up being 11.1. So I have both my sides using law of sines. And I knew I didn't have an ambiguous case because they gave me two angles, so I knew what was good. So now area, I tend to do, I did 1/2 11.1, which was k, times 12.5, which was j, times the sine of 107. So again, I'm doing this little triangle, or this little trio there, and I got area to be 66.3. Done. Okay, word problems. Read this word problem. They give you the sketch already. So you're use a diagram to find the distance from Dayton to Sunshine. So you need to find little side C. Looking at this, what do you think? The setup is side, angle, side. I don't have a pairing. I have no choice but to use law of cosines. So I'm going to write it out for myself. I want to find C squared, right? So I'm going to say that's going to be S squared plus D squared minus 2 SD cosine C. Remember, you've got to work out how you're going to arrange these equations. So to get C, as I'm plugging things in, it's going to be 3.8 squared plus 8.2 squared minus 2 times 3.8 times 8.2 times the cosine of 14 degrees. That goes in my calculator, and I get C to be 4.6. They gave me units, so I give units back in my answer. 4.6 miles is the best answer. Okay, that brings us to two more word problems. Once again, they gave us pictures. Whenever you see something like number 23, what you're going to do is you're going to try to fill in all the other missing angles. I'll do them in red so you see the contrast. 30.2 and the angle next to it forms a linear pair, which means it equals 180. So I now know that this angle right here is 149.8. That gives me two of the three angles in this little triangle. So the missing angle, just subtracting what I have from 180 gets me an angle of 6.1 degrees. Then I have an assumption here that this building is standing upright. It's a right triangle, therefore. I need to find the height of this building. I know that this angle down here is 30.2. I can now, by subtracting from 90, because those two angles, those two acute angles in a right triangle are complementary, this is 59.8. Okay, so what I said to myself was, I'm going to use the right triangle that's next to the building, but I need to have the hypotenuse in order to use it to be able to solve for the height. To get that hypotenuse, I'm going to use the oblique triangle that's created by the red dashed lines. In that oblique triangle, I have enough information to be able to use law of sines to find the missing side. And the side that I want to find is this little side A. So I'm going to say the sine of 6.1 over 600, that's the magic pairing, equals the sine of 24.1 over little a. When I do that, I get little a to be 2,305.6, and that's going to be feet. Okay, so this is now 2,305.6 feet. So now I can use that as the hypotenuse of the right triangle to get the missing vertical section. So my second equation is going to be SOHCAHTOA. So this was law of sines, and now I'm going to use SOHCAHTOA. And I have an angle. So from that angle's perspective, I need the opposite, and I have the hypotenuse. Opposite of a hypotenuse is going to be sine. The sine of 30.2 equals opposite, which is what I'm looking for, over 2,305.6. And using those numbers, I get height of 1159.8. And this is in feet, and that's my answer. So you may want to go back through and really think about this. This is a lot of stuff for you to study and digest. Okay, next thing. The distance between the boat and the shore. A boat is cruising the ocean off a straight shoreline. Points A and B are 120 miles apart on the shore as shown. It is found that angle A is 42.3 and angle B is 68.9. Find the shortest distance from the boat to the shore. So that's interesting. So that means they want a vertical line. They want an altitude. So, but before I can get the altitude, I'm thinking I'm going to have to do some other things. First off, why don't we find this missing angle right here? Because that's easy enough, right? Because we have two of the angles. So 180 minus those other two angles is going to give me an angle of 68.8 degrees. Okay, so that's one thing. Now, I really need to have, if I think about this, what they want me to do is they want me to drop this altitude. That is the shortest distance. A straight line, remember, is the shortest distance. That's an altitude. I need to find this value. And I can use right angle trig to do that, but I first need this value. So I'm going to use law of sines to find little side A. So this is little side A. This is going to be the height. Okay, so think about what we have. Look back at the original triangle. And I have a magic pairing. And that pairing is the sine of 68.8 over the 120 equals the sine of 42.3 over a little side A. Little side A equals 86.6. So this now equals 86.6. So now I have a right triangle. So I'm going to redraw it like this so you can see it more readily. Here's my right triangle. I need the height. I know the hypotenuse is 86.6, and I know this angle right here is 68.9. So I can say from 68.9's position, the sine of 68.9 equals, whoops, so sorry, let me get back up there, equals, let me do it under here. So hold on, I'm going to take that and I'll move it down here. And I will put that line back. Okay, so the sine of 68.9 equals opposite, which is the height, over hypotenuse, which is the 86.6 we solved for. Doing just cross products one step, I get my height is 80.8 feet. Okay, here again, this is a lot of thinking because you had a two-step problem and you had to kind of work backwards a little bit to figure out what you needed, and you had to understand that the shortest distance is a straight line. So a lot of thinking going on. So go back and study this. Make sure you understand what I just did. Okay, so I'm going to do another video on the last problem. So I'm going to stop this video here, and I'll do the other video in just a moment. Okay, on second thought, I think I'm just going to write in what we have. The next 4 problems ask you to determine whether 1, 2, or 0 triangles exist with the given measures. This is the ambiguous case. So, problem 25 gives you the following measurements. You have A is 12, C is 8, and then A is 100 degrees. Okay, so I'm going to draw that triangle, and you have the type version of this. I'm just writing it in to make it easier for me to get this video done. This is ABC. This is 100 degrees. This is little side A. And then C is 8. Okay, so the first thing I have to do is I need to figure out if I can find angle C. Now, ambiguous case is very obvious to me because I see they only gave me one angle and I have a pairing. So that means it's going to be law of sines, but ambiguous. So I'm going to say sine of 100 over 12 equals sine of C over 8. So what I'm going to do now is say 8 times the sine of 100 equals 12 times the sine of C. Divide both sides by 12, and then take the inverse sine of the expression on the left, and I get that angle C is going to end up being 41 degrees. So then I say, okay, what is angle C's supplement? Because I know it has the same cosine. Excuse me, it has the same sine. So if I say 41 minus, well, I guess 180, excuse me. 180 minus 41, I get 139. I cannot add 139 to the 100 I currently have. So too big. So therefore, I only have one triangle. Okay, so my answer is going to have one triangle. Let's finish solving the rest. I just got angle C to be 41. I can't make a second triangle. What's my angle B? Subtract from 180, and you will get angle B to be 39. Okay, then I'm missing little b. So use your law of sines, which is sine of 100. Use the pairing you had. Sine of 100 over 12 equals the sine of 39 over little b. And you will get little b to be 7.7, and you have solved for the triangle, and you did not have a situation where you had more than one triangle or a situation where you had no triangles. Okay, let's go to 26. So 26, on your typed version, they tell you that B equals 4, C equals 6, and big B, or angle B, is 51 degrees. So draw that for yourself so you can kind of see where you are. And I made this ABC. This is 51. This is 4. This is 6. So I tried to do sine of 51 over 4 equals sine of C over 6. And when I tried to solve for the angle, I got an error. So this is not a triangle. Okay, so no solution is possible. That brings us down to the next two. So let me do these over here. So 27 tells us A equals 7, B equals 9, and angle A equals 40 degrees. Okay, so draw that triangle for yourself. So A, B, C, and this is 40, this is 7, this is 9. So I set up my magic pair. Sine of 40 over 7 equals sine of B over 9, and I get angle B is 55.7. Now, when I take 180 minus 55.7, I find that the supplement is 124. If I add 40 to that, I'm still under 180. So therefore, I am going to have two triangles. So I'm going to start building my two triangles right away. So here's my second triangle. Use the same demarcation, 47, 9. And the first one we found that this was 55.7. That was a missing angle we found. When we found the supplement, it was 124.3. That works for a triangle. Find the missing angle in each one by doing subtraction, and you will be getting 84.3 in the first triangle, and you will get 15.7 in the second triangle. Okay, find the remaining missing side C. You need this side and this side in both. So, using the first pairings, I have sine of 40 over 7 equals sine of 84.3 over little c, and I get little c is 10.8. Done. Bottom triangle, when I say sine of 40 over 7 equals sine of 15.7 over c, my c is instead much smaller at 2.9. But now you have solved both triangles. So that was 27. Two solutions. Ambiguous case. Let's go. I'm going to draw a line here. And here's our last problem in the set, 28. So if A is 6 and B is 8 and angle A is 35 degrees, what do I have? Well, let me draw a triangle and we'll figure this out. So A, B, C, I'm open to the ambiguous case because I have one angle only. This is 35 and I have a pairing. So that's why I know it's law of sines. And they gave me this 8 over here, but I don't know whether I have 1, 2, or 0 triangle. So let's try to solve for it. So sine of 35 over 6 equals sine of angle B over 8. Remember, you're going to do cross products, and then you're going to do inverse trig, and you get an angle of 49.9. Well, what is its supplement? Its supplement would be 130.1, and if I add that to the 35 that I got, that I was given rather, I can still make a triangle. So I know that I now have 2 triangles. Go ahead, take that 130, and we're going to put it in the second triangle. So down here, I'm going to draw my second triangle, which is going to have the same orientation, the same givens, but now my B angle for the first one was 49.9, and my B angle for the second one is 130.1. Okay, so that's this B angle right here. So then you can calculate by using mere subtraction what the other angle is. So far I've solved for this and I've solved for this. The other angle that I have to solve for is the C. I'm just going to do subtraction to get that. And I get 95.1 degrees up top and only 14.9 degrees down below. Okay, so now let's use our magic pairing. Sine 35 over 6 equals sine 95.1 over C to get the remaining missing side. 10.4 is the missing side for the top triangle. Let's do the same thing down here. I have the same initial pairing, but now I'm going to use the sine of 14.9 over C, and in this situation I get C is 2.7. So here's 2.7. Okay, so that ambiguous case gave us 2 triangles, and we are done. So go back, you have a lot to study. Do not take this lightly. Do not just think it makes sense when I do it. Surely you can figure this out. You have got to practice this, and you have to practice this for a little bit, because this does not come quickly. You want to have a good sense of this going into the test. So thank you for listening.